The creation of artificial intelligence is not merely a software challenge, it is a heavy, physical manufacturing industry. This comparison illustrates the physical footprint. Generating one ChatGPT response requires 10 times the electricity of a standard Google search. As the industry shifts towards autonomous agents and artificial general intelligence, this baseline demand for power is moving into a state of exponential growth. Our energy infrastructure was never designed to handle a load of this scale, creating a massive physical bottleneck for the entire technology sector. Gartner projects that by 2027, AI data centers will consume 500 terawatt-hours, an amount of energy that exceeds the annual usage of the entire nation of Japan. This sudden spike in demand has triggered a corporate panic, with tech giants securing power from any available source to keep scaling projects on track. In Pennsylvania, Microsoft is underwriting the reopening of the 3 Mile Island nuclear plant to provide a dedicated power supply for its AI operations. To the south, Elon Musk's xAI is powering its Colossus supercomputer using gas turbines that release significant levels of hazardous pollutants into the local atmosphere. The energy required to train and run these models is currently scaling faster than the renewable grids intended to sustain them, creating a major conflict between technological growth and climate obligations. How does the industry continue building these models without permanently damaging the global power grid? Australia is positioning itself as a central hub for this transition. The country is leveraging its vast landmass to tap into some of the highest concentrations of solar and wind energy on the planet. This has led to the development of green data centers, facilities built at the direct source of renewable energy that process data using clean power before it ever hits the public grid. This is Perth, the site of Green Square DC's WAI-1 facility. Because AI servers generate extreme heat, this site uses liquid and groundwater cooling systems, effectively eliminating the need for massive electricity-heavy air conditioning units. In the AI era, strategic advantage is determined by proximity to energy and cooling rather than proximity to human population centers. This enables a new economic model where renewable energy is exported as a finished product rather than a raw resource. Global technology firms send continuous streams of raw data across the ocean to Australian hubs. That data is processed using the local renewable grid to train a new model. Once finished, Australia beams the completed intelligence back to the global market. Australia is effectively selling processed intelligence, turning its renewable energy grid into a high-value export hub for the global digital economy. Building this new digital backbone requires navigating a set of rigid physical constraints. The primary bottleneck is latency. Data centers must be close enough to renewable farms to secure power, but near enough to global fiber networks to prevent a lag in the AI's response time. These projects also face a global shortage of high-end server hardware and domestic planning systems that often take years to approve new power infrastructure. Raw natural resources only provide an advantage if a country has the legislative speed to build the infrastructure faster than its competitors. A recent RAND study notes that leadership in the AI era is not determined by code alone. The nations that succeed will be those with the social and political agility to overhaul their physical power grids and industrial supply chains in time to meet the demand. By aligning its policy with these infrastructure needs, Australia can transition from its history as a 20th century mining quarry to becoming the sustainable engine of the global digital economy. The massive energy demand of artificial intelligence is currently providing the financial and political momentum to accelerate the global renewable transition.